This is the unit about solutions. Before we start talking about solutions, let's go over mixtures again. So a mixture is a combination of two or more substances where each of the substances still retain their own properties. So heterogeneous mixtures are mixtures where the two substances do not blend smoothly throughout the mixture. So this would be like muddy water. A homogeneous mixture is a mixture where the composition is the same all the way through. So that would be like salt water. A solution is any homogeneous mixture. There are two parts for each solution. The solvent, which is the largest part, what you have the most of, and the solute, which are the smaller components, what's dissolved in the solvent. You can have more than one solute, but you can only ever have one solvent. So some types of solutions. A gas solution, you would have air. The solvent is nitrogen gas. The solutes are oxygen, water, and argon. A liquid solution could have ocean water. The solvent is water, and you have salt dissolved in it. Or Kool-Aid, where you have water with sugar, flavoring, and food color. Or a solid, like steel, which is iron is the solvent, and carbon is the solute. A substance that can dissolve in a solvent is soluble. Two liquids that are soluble in each other are called miscible. A substance that cannot dissolve in a solvent is insoluble in that solvent. Two liquids that can be mixed together but separated are immiscible. That would be like oil and water. The solubility is influenced by polarity, particle size, temperature, and pressure. Polarity. This means that like dissolves like. So polar molecules will dissolve in other polar solvents. Nonpolar molecules dissolve in nonpolar solvents. Water is polar and it attracts other polar substances. So remember that polar is like with water. The electrons are held a little more closely to the oxygen than they are to the hydrogen, and so the oxygen has a slightly negative charge while the hydrogen is slightly positive. Particle size. So smaller particles tend to be more soluble than larger. Temperature. Dissolving does require energy. Most of the solids will dissolve more when a solvent is warm. The gases are the opposites. Gases will actually dissolve less at higher temperature. Gases dissolve more at a higher pressure, but pressure doesn't affect solids or liquids. Types of solutions. Unsaturated solutions. An unsaturated solution has a low concentration of solute. So more solute can be added, and it's going to dissolve as it's added. A saturated solution has the maximum amount of solutes possible at that temperature and pressure. If you add it, it will just sink to the bottom. Nothing else is going to dissolve. Supersaturated solutions. Solubility is affected by increasing the temperature. So a supersaturated solution contains more solute than is normally possible in a saturated solution at the same temperature. To make supersaturated solution, the solution is heated to increase the amount that can dissolve. Then it's slowly cooled. This type of solution is very unstable. So crystallization can occur if a type Crystallization can occur if a small amount of solute is added to the solution. It can also occur if the container is scratched or the solution is stirred or tapped. So these are very, very unstable. Solubility curves show how the solubility of a solution or substance changes with changes in temperature. Solids will have a higher solubility at higher temperatures. Gases have a lower solubility at high temperatures. So this graph shows different solids, and they increase as the temperature increases. These are different gases, and the solubility decreases as the temperature increases. I've already mentioned that water is a polar molecule. So the oxygen holds the electrons more closely, so it's slightly negative, and the hydrogens are both slightly positive. Since water is polar, it can interact with other polar molecules. Remember, like dissolves like. So polar molecules will dissolve other polar molecules, and nonpolar can dissolve other nonpolar. The positive regions in the water molecules are attracted to the negative regions in other molecules. Water can dissolve most substances, and this is why it is called the universal solvent. The polarity of water is so strong that the hydrogen atoms of one molecule will attract the oxygen atoms in another molecule. This is called hydrogen bonding. So you can see that there's a very weak bond, a hydrogen bond, between the oxygen of this molecule and the hydrogen of each of these molecules. This gives water many of its unique properties. Water is cohesive. That means that the water molecules stick to each other. And this is why it has surface tension and can form drops on smooth surfaces. Water is also one of the only liquids which expands when it freezes. This is due to hydrogen bonding. Water molecules freeze with all the positives facing negatives, which means there's a lot of empty space in the solid that are not present in the liquid. Water also has adhesion, which is the force of attraction between water and other polar molecules. Because of the attraction between the water molecules and the glass in a graduated cylinder, we see the meniscus. So the meniscus is that curved line when water is put in a container. So the water is more attracted to the glass in the container, which is why it curves up at the edges. The surrounding of solute particles with solvent particles to form a solution is called solvation. In water, when water is the solvent, it's called hydration. For a substance to dissolve, the intermolecular forces have to be broken. This happens by solvation and or dissociation. Covalent compounds will only undergo solvation. Water can break the forces that hold the molecule together, but it doesn't break those covalent bonds between the individual atoms. Ionic compounds and acids do break apart into ions. This is known as dissociation. Polyatomic ions do not dissociate because they have those covalent bonds. When ionic compounds and strong acids dissociate in water, they can conduct electricity. So you saw that in our ionic covalent lab at the beginning of the year. These compounds make electrolytes. Polar compounds will not conduct electricity, and we call those non-electrolytes. So there are rules for solubility for the compounds that will dissolve in water. The solubility chart, which is also on your green charts, is organized mainly by anions. Anions, remember, are the negatively charged part of the compound. There's a solubility chart, again, on the back of your green charts. So determine the solubility of each compound. So HBr. So we're going to look at the anion, which is bromine. So it is soluble most of the time, and the only exceptions are silver, lead, and mercury. So this isn't one of those this isn't one of the exceptions, so it is soluble. Now we have SrSO4. So we would look at sulfate. And this time, compounds of strontium are an exception, so this would be insoluble. Silver chloride. So silver is one of the exceptions, and it would be insoluble. We have bromide again, and lead is one of the exceptions, so that is insoluble. So the top of the chart, these are compounds that are normally soluble in water. The first ones here, they have no exceptions. So if you see anything with NH4 or NO3, it will always be soluble. The bottom half of the chart, these compounds are normally not soluble. The exceptions would be NH4 and group 1 metals. And then for OH and sulfide, there are a few other exceptions that would be soluble in water. So concentration is the measure of the amount of solute that is dissolved in an amount of solvent. A solution that contains a lot of solute relative to the solvent is concentrated. A watered down solution would be considered dilute. The concentration can be expressed several ways. Percent by mass is the mass of the solute divided by the mass of the solution times 100. Percent by volume is the volume of the solute divided by the mass or the volume of the solution. And this is the total volume of the solution, not just the solvent. Molarity, which is moles of solute per liters of solution. This is the most important one and the one that we will be using. Molality, which is moles of solute divided by kilogram of solvent. And mole fraction, which is moles of solute divided by moles of solute plus moles of solvent. So molarity is the most common method of measuring concentration. And so our formula for that is molarity equals moles of solute divided by liters of solution. The first example is, what is the molarity of an aqueous solution containing 40 grams of glucose and 2.5 liters of water? So the first thing we need to know is our molar mass of glucose, because we need moles and we have grams. So 1 mole of glucose is 180.156 grams per mole. So we would convert our 40 grams to moles. And we get 0.210 moles of glucose. Now that we have moles, we can use our molarity formula. So molarity is equal to moles divided by liters. So we have 0.210 moles and 2.5 liters. So we end up with 1.089 molar glucose solution. So to find molarity, you are always going to use moles of solute divided by liters of solution. So find the molarity of a 2.4 liter solution that contains 2.5 grams of KBr. So we need the molar mass. So 1 mole of potassium bromide is 119.002 grams per mole. So we have 2.5 grams of KBr times 1 mole over 119.002 grams of KBr. And we get 0.21 moles. Then we can take our moles and divide by our liters, so 2.4 liters, and we get 0.0088 molar KBr. Now the symbol for molarity is either capital M or moles per liter. A dilution is made when you have a concentrated solution and you want to make a dilute solution. So the formula is M1V1 M2V2. So that is the molarity of solution 1 times the volume that you transfer of solution 1 is equal to the molarity of solution 2 times the total volume of solution 2. So if you have 45.45 liters of 0.25 molar HCl is diluted to a final volume of 2 liters, what is the new molarity of this solution? So we start with what we know. So 1 M1 V1 M2 V2. So our molarity of solution 1 is 0.25 molar HCl. We have 0.45 liters, and it's diluted to a final volume of 2 liters. So V2 is 2 liters, and we are looking for M2. So we have M1 V1 equals M2 V2. M1 is 0.25 molar. V1 is 0.45 liters. That's equal to M2 times 2.00 liters. So when we solve for M2, we get 0.0 0.56 molar solution. So the next problem, we're going to start the same way with writing down what we do know. So M1 is 12.2 moles. V1 is 0.45 liters, 0.045 liters, and we're adding that to 500 milliliters of water. So we have 500 milliliters of water plus our 45 milliliters. So our final volume is 0.545 liters, and we are looking for M2. So we have 12.2 molar times 0.045 liters is equal to M2 times 0.545 liters. So again, we're solving for M2. This time you get 0.99 molar HCl. So the rate that chemicals can dissolve can also be influenced, and this is known as the rate of solution. Things that are going to influence the rate of solution are temperature, agitation, pressure, and surface area. So solids are going to dissolve more quickly and in greater amounts with higher temperatures. Gases will dissolve less. Stirring and mixing, a solid will also increase the rate that it dissolves. Gases dissolve faster under high pressure, and pressure has little to no effect on solids or liquid. And solids that are broken down into small pieces will dissolve more quickly. Okay, so that is the end of the slideshow. Make sure that you go to the next page and complete the practice questions. There are 30 questions, and put in your answers on Schoology.